In this example, we have a helicopter which is lifting a truck. We are given that the mass of the helicopter, let's label it as mh, is equal to 16,500 kilograms. The mass of the truck, which we'll label as mt, is given to be 4,100 kilograms. And the helicopter is lifting the truck with a given acceleration. The acceleration is given to be 3.7 meter per second squared. And the question is, what is the force that the air exerts on the blades of the helicopter? Now, whenever we have a question on Newton's laws, the first thing you do is you draw a free body diagram. Let's abbreviate it as FBD. And let's now draw a free body diagram for the entire system, which consists of both the helicopter and the truck. I will represent the system with just a point. Okay, so this point is both the helicopter and the truck. So it's the system. So what are the forces that are acting on the system? So there is a gravity force which is pulling it downwards, and that is equal to the total mass times free fall acceleration. So let's say that the total mass m is the mass of the helicopter plus the mass of the truck. And then there is a force that is pulling it upwards. That is the force that the air exerts on the blades of the helicopter. That's why I have a subscript A, Fa. And the acceleration is pointing upwards. So the system is accelerating upwards. So this is the free body diagram for this problem. We have the forces and we have the direction for the acceleration. So now we are ready to write the Newton's second law. The Newton's second law states that the sum of all forces is equal to the mass times acceleration. So in our case, we only have two forces. So the force of the air plus the gravity force equals ma. Now, in order to find the magnitudes of the force of the air, we need to get rid of the vectors. To get rid of the vectors, we first need to introduce the positive direction. So let's say that the upwards direction is a positive direction. Now, the choice of the direction, which is to be positive, is arbitrary. You can choose the direction to be pointing downwards as positive, and it will not change the final result. So I've chosen the upwards direction as a positive direction. And now we look at the vectors themselves. So the force of the air is pointing upwards as well, so it has a positive sign to it. So instead of Fa vector, I'll just say Fa. Now the weight is pointing downwards, so now when I get rid of the vector, I should write the minus sign here, minus mg equals mass times acceleration, and acceleration is pointing upwards as well, so it is positive. So basically what we're doing here by introducing this direction is we're looking at the projections of these forces on that axis that we've introduced. So now we can calculate for the force of the air. So this is equal to the total mass, A plus G. So this is, the total mass is the sum of 16,500 plus 4,100 multiplied by the acceleration, which is 3.70, plus the free fall acceleration, which is 9.81. So if you do the math, you should get 2.28 times 10 to the power 5 newtons when written to three significant figures. So this is part A of the problem. Now part B. In part B of the problem, we need to find the tension that the upper cable exerts on the truck. So, just as we did in part A, let's start by drawing a free body diagram. But now, the system that we're drawing a free body diagram for is not the helicopter and the truck, but just the truck itself. So this point is representing the free body diagram for just the truck. So what are the forces acting on the truck? Well, there is a gravity force which is pulling it downwards, and that's the gravity force of the truck itself, so mtg. And then the tension in the upper cable, which is pulling it upwards. The truck is accelerating upwards as well. So the acceleration is pointing upwards. So this is the free body diagram for the truck. Let's start by writing the Newton's second law. The sum of all forces is equal to the mass times acceleration. In this case, the mass is not the total mass, but the mass of the truck itself. The forces that we have are tension plus gravity force equals mta. Again, to get rid of the vectors, we need to introduce the direction, which we take as positive. So let's say it's the upwards direction. And now we look at the tension. Tension is pointing upwards, so we just write T. mtg is pointing downwards, so it goes as minus mtg. MTA is pointing upwards. So now we can calculate for tension, which is MTA plus G. And this gives us mass of the truck is 4,100 kilograms. Acceleration is 370 plus 9.81. And if you do the math, this should give you 5.53 times 10 to the power 4 newtons. That's it.